Okay, so I want to go over 3D printing with everybody. There's going to be several components to that stuff, which, as I said, we're going to be going over the file types themselves, what you need to solve, or how you need to export from Fusion as certain file types, and obviously the 3D printers themselves. So let's start there. Now, in class, there's of course a wide range of 3D printers available in the market. We're going to focus on the ones we have and also the ones that we're going to be using. So outright, we have two main types of printers at our disposal, and there's two main types of printers that are commercially available. Are there more? Yes, we're going to focus on these. FDM and SLA printers. And this is an article from all3d.com, or no, is it all3d? I always forget what it's called. Yeah, all3d, DP, whatever. Anyway, excellent resource for the stuff. Got some other stuff there. So first is the 3D printers we have that are filament type, FDM. As it says here, FDM is abbreviation for filament deposition machine. Basically, think of this as a hot glue gun on a control board. It takes a spool of a type of plastic, it heats it up, pushes it through a hot nozzle, and squirts it out as the control arm moves that nozzle around. As it finishes one layer, either depending on the type of printer, the bed will move down, the head will move up, that sort of thing. That's how, and then it'll start again, and it will create a stacked layers of single layer images. And that's essentially how any of 3D printing works. Not all, but a lot. Now, of course, there's going to be a variety, and if you're trying to get some, if you're looking into getting some on your own, there's a course for every budget, because yeah, duh, of course they are. They want you to buy them. We use in here, I really enjoy this type here. This is a PRUSA, or I'm probably mispronounced. I believe it's pronounced PRUSA. I forget. It's out of the Czech Republic. It's an excellent mix of quality, reliability, and price. Now we have two over here on this side. This is very similar in type as the like your Enders. Your MakerBot is slightly different, as we have this other one here that looks like a large cooler. That is a fully contained one. The only difference is there is it's contained within its shell, and it's got the little environment. The open frame ones here do not have a shell. You don't necessarily have to have a container around it, but it can certainly help with, especially with specialty filaments. Your spools are regularly around $20 to $25 a spool. They usually come in kilogram spools. So it's really very available. These will print, the PRUSAs will print a wide variety of filaments. This MakerBot will only print PLA type. We're going to get into exactly what that means. We also have resin printers, the SLA printers. These are stereolithogram apparatus. Yeah, they're basically the same damn thing. It's just a different way of working. Only difference is, instead of a glue gun, this one uses lasers. Yeah, it's literally uses a UV sensitive resin. Different types of resins. There's epoxy resins. They've actually, I'm trying to get some for these. They even make flexible resins. There are flexible filaments. There are some that can be directly cast into jewelry type, such like that, where it could be used to create, it can be melted out of a intermediate like plaster, and then you can heat up the wax that is printed from this, melt it out, and then pour in hot metal into that. Very cool. But it uses just like I said, it uses UV laser to create images, in that the resin bath floating above the laser is UV sensitive, which is why it has this orange shroud around it. That is a UV protective shield. Also, protects people in the room from getting blasted in the eyes with a UV laser. But what it does is it shoots laser basically just like a laser printer, really just like a laser printer. And then for each layer, the bed moves up a little bit away from the laser, prints again, and keeps stacking, and it just hardens against the previous layer. You can read through this article in more detail, but that's essentially how it works. They're very similar in how they work. They're extremely different in the materials and costs. One of the some of the main differences versus, and as we go into here, materials and colors. Now, this article is a couple years old now, so of course that means there's been vast improvements and changes to a lot of the stuff. Your FDM printers, your filament printers, will print a variety of stuffs. PLA, PETG, ABS, which are the most common ones. There are also different now types. Like nylon, so it'll actually print functional objects as well, because your standard prints, PLA, PET, PETG, and ABS, while can be strong, these materials are still very much meant for prototyping. They can be used in low impact purposes, things like phone holders or odd desk projects, things like that. But you cannot go print like a car part and take it directly to. And as soon as I say that, yeah, you can, because there's some people print car parts, things like air ducts and like shifter knob caps, things like that. So low impact stuffs, you're good. You cannot print an engine part in these plastics. Again, it's still plastic, so it doesn't even matter that it's strong enough, it'll melt. So there's that. SLA has a variety as well. They can very often do a lot of the same, but big difference there is that filament is very cheap and widely available. Resin printers, resin is can get extremely expensive, and we are using a Formlab printer, so their printer resins are proprietary, meaning they are the sole supplier of those resins. You can get others, but these Formlab resin printers will not accept them. Other brands, other makes. PRUSA now also makes their own resin printer. Another difference being that, as you can see from the different sizes here, those PRUSA ones will print about, I think it's not fully 200 millimeters cubed, but it's close to that. And the MakerBot here is about twice that in height. Much larger print area. As you can see from the resin printers over there, the Formlabs, much smaller, roughly 150 millimeters cubed, or about 6 inches cubed. So roughly in there. Difference also, much higher quality in resin. You can get extreme detail. So if you were printing things like, if you learn modeling to the degree of sculpting and such, you could get extremely high detail in very small amounts, things like tabletop figures and things like that. You could still print those with the filament printers, but there's a limit. The limit being the size of the extrusion nozzle. You can get different extrusion nozzles. Ours are 0.4 millimeters, quite small, but it's a good general size. So those are the real pros, cons, big difference. Filament printers, a lot cheaper to operate, not as high quality, tend to be larger build volumes, wide variety of materials. SLA printers, much more expensive to operate, but also much higher quality prints, much smaller capabilities, and can't really say that the materials are not wide. There's a wide variety of materials for them too, but they are vastly different. So that's essentially the thing. And that's what this goes into here, precision and smoothness. The FDM printers, the filament printers, they can be really quite detailed. It is generally quite surprising how detailed they can still get. But again, the SLA resin printers are going to be much higher. We have some elements of adhesion removal of 3D printing. One of the main functions of printing is, like I said, it goes layer by layer. So the most important part, that first layer, your object is sticking to whatever print bed it has. These PRUSA printers actually have a magnetic table, so you can lift the metal sheet off and it flexes a little bit. Don't bend it in half, but you can flex it slightly. So especially if you have a larger platform thing like this first project, it will flex, pop off very easily. This MakerBot has a rigid platform, but the platform is removable. So at least you can take it out of there and you can scrape it off pretty easily. The resin printers do not have either of those. You can remove the entire build platform out of that, but then you have to kind of scrape it off with a metal chisel, metal scraper. You don't want to gouge. You would be very careful with that because it is a soft aluminum platform. So, but at this point, resin printers are starting to develop aftermarket kits to have that same flexible platform capability, so it's easier to remove prints. So again, different stuff. Post-processing. Filament printers, you're going to often have supports. We're going to go into what that is. It looks like scaffolding around an object, because as you're printing, obviously one of the things you're dealing with is we live on Earth, gravity. So it deposits material. It has to have a place to deposit. If your object has an overhang, which is, say, something like hanging out, so it overhangs space, it has to have some support there. That's all that means. Resin printer will have the same, only it's printing upside down. Same issue, different orientation. All that means is you have to clip the things away and potentially sand them smooth. The resin printer will need to clean with isopropyl alcohol or some sort of solvent, because it will be still coated in its originating UV sensitive resin. You need to wash that off before exposing it to ultraviolet light, i.e. like the sun, otherwise you'll have a very high detail object that has been completely gooped over and looks like it got mildly melted by, I don't know, slightly toxic Avenger stuff. Anyway, I've already gone over material costs, stuff like that. Reason to use, there's a variety of reasons. Mainly it comes down to what you have available as far as funds and access to. We have access to both. This first project will be focusing on the filament printers. And for those of you that are looking outside of the class, stuff like that, there are printing services. Yeah, this is already a 2-year-old article. There's still plenty of them. But there are online services that you can set for a price. You can send them your files and they will print them. Benefit there, you do not have to maintain and or even purchase outright a printer. The speed at which printers are evolving and improving is year to year. So a lot of them are decent investment, but some of them increase the quality and the capabilities increase so quickly that it almost isn't cost effective to run unless you are in a group environment like this. So that's the basic rundown of what we got going. Okay, so the next step, you've got your object, and let's just open up Fusion here. I'll bring up the example I was working on, my little Jedi badge thing. After it, come on. Okay, I've got my object. I have gone through all the elements. It is a single object that has been combined into one from all the different extrusions. We're good. How do I get my object out of Fusion, and in what way should I do that? Now, technically, Fusion does have a direct 3D print function. When you go to File, below Export, which is what you normally would expect to hit, you have 3D print. Pretty self-explanatory there. Now, we are not going to be using this function simply because the proprietaries for PRUSA are a little bit better, I have found. But you can use that. You have your print utilities. You have different ones. It will go straight to Preform is one of the ones built in. That is the proprietary software for the SLA Formlabs printers. So you can go directly into that, or you can download it separately. That's fine. You have Print Studio for Fusion. It's fine. There's really no problems with it. I personally prefer using the featured PRUSA software for that. For MakerBot has its own. I will be going over, there's a more universal one called CURA. It is a universal program that has its pros and cons as well. We'll go over that in a moment. But, pardon me. So let's just say, nope, I don't want that. I'm not going to be sending to a 3D printer. But, excuse me, like any file saving, you have your selections. Well, select, I need to figure out what I'm doing. Make certain, even if your whole thing is joined into one, make sure you have it selected entirely. So you should be able to just select the object as one if it's selected as a single object. But you can also go to your hierarchy tree, open up, in this case, bodies, select the badge, There you go. Format. Now, this is where we're going to break away from. Open that. We have a variety of options. What does all of this mean? Well, your standard file format is STL, stereolithography. That is basically, lithography is a printmaking term. It's for a single flat surface, and we're making a stereo, meaning it is a dimensional thing. Stereo or STL is the basic and actually oldest format. With that, pardon me, I'm so sorry. So I realized that it was not recording properly at that point. I did not have the proper screen going. So I opened up my object. I made sure that's a single object, select the object. I went to, let me cancel this. I went to my files selection, 3D print. This has, as I said, Fusion has its own built-in 3D print utility. We're not going to use that because there are better ones. It's perfectly fine. There's nothing wrong with it, but there are better ones. So I'm going to deselect the checkbox for send to print utility. I'm going to make sure I've selected my badge here. You can either, if it's properly all unioned, or sorry, combined, you can select just the badge or go to the hierarchy tree, select there. The format is what we're talking about. STL is the standard. STL is the first type of file saving format for 3D printing. It's a 20-year-old format. Is there anything wrong with it? None whatsoever. Is there anything wrong? Is it a problem for this first project? Not at all, because it's a very basic type. So the other ones, you have OBJ, an object file, and there's now a new format called 3MF. This is a brand new format. So let's discuss these. Let me switch over. First and foremost, object file or STL. What is the point? What do they do? There you go. You're saving it as a three-dimensional model. Basically, the differences on these, and these are all universal, any of the formats can translate into the slicer programs. Doesn't matter outright, but I need you to know the differences. So an STL, it is the simpler of the two. Ultimately, what it does, as it says, stereolithography, it's a standard format for CAD software. Great. What it does is it converts the entire model into a series of surface facets and faces made up of triangular faces. Now, the more complex the object, the more faces, ideally. The downside of that is it isn't really capable of high fidelity. If you have a more complex model, it can do that. It can work perfectly fine, but it can, depending on the quality of the model, the quality of the save, it can start to tessellate, which means it has a variety of broken surfaces and such. However, it works perfectly fine for simple models, especially with this. We're working with a series of flat surfaces, so really a non-issue, or essentially flat surfaces. The other thing, which won't really be a issue for this class, but for more of if you are doing CAD work in software with you are also modeling surface textures, texture maps, colors, things like that, like applied materials. The file STL type format will not save any of that. Is that relevant to what we're doing right now? No, but possibly you are considering going into or already playing with like animation programs or more involved sculpting programs, things like that. That will not be saved. So there's the other version, OBJ, an object file format. This will still operate in any slicer programs. This has more complex geometry information saving capabilities. So what that means is instead of straight trigonometry facet or triangle facets, so trigonometry-based facets, it tends to use much more complex and what is called NURBS, non-uniform rational B-splines. Really, to break that down into what the heck does that actually mean? It's a better surface management type of software, or it's a better surface management type of file saving. It works better for more complex surfaces, especially sculpted surfaces. Again, if you're doing like modeling, things like that, like sculpting, digital sculpting, it is much more capable there. It can get to much more complex and larger file sizes. That is a downside. But also, it can save color and texture information. You got color maps, material information, things like that. One of the things that Fusion can, in fact, do, it will save that information. So that's the benefit. Which one do you use? Well, normally I would say for most of the stuff we're doing in this class, just use an STL. It's perfectly fine. Object file can work better. It can be a more complex file, especially depending on how complex your objects are. And that's pretty much it. Both of these articles are available on Blackboard. The other one I want to talk to you about is the newer 3MF. This has come about in the last several years, like very, very recent. It has been the reason for it is it is a universal file saving type. The point is it has been made as a open source freeware sort of file saving, and it has been produced exclusively for and with modern 3D printing in mind. It was developed by a collection of 3D printers or 3D printing companies and CAD software companies. So it is designed specifically for all of that. Does that negate any of the previous models? No, not at all. Can you still use them? Are they still functional? Yes, absolutely. This is simply a new type. The difference there is it combines the best of all those worlds in that it still saves much more complex geometry, as we'll dial down here. You can see by the adorable little soft bunny there. It does not tessellate the surfaces. It does not fracture the object up, depending on your the fidelity that you choose to select it in. Now, can you dial it back to save information? Yeah, absolutely. But it doesn't do it as badly at all, especially if you choose a higher fidelity. The other option is that it does, in fact, translate both texture mapping and color or material information in an object. So if you were to take an object saved out of Fusion that has, hey, I built this thing out of, it is designed to be built out of stainless steel with nylon lock washers and I don't know, galvanized hardware. All of that information that you have applied to that model, if you were to export that as a saved file in a 3MF format and open it up in another program, say like Rhino or SolidWorks, it will maintain the information on it. That's why. The other thing is it has an excellent, or rather a much better compression ratio. So if you save in a high fidelity format, it will not have a massive data point like, or data count rather, like an object file. So it is designed to compress that. And it talks about it here in the first type. Kind of equate this to a universal PDF format. Your other file types, like, excuse me, like Word and such, will save your file as a document docs or .x, that sort of thing. It can only be opened really, truly properly in another Word program. PDF can be opened in any program and it'll keep all the proper information, that sort. Think of a 3MF file as that. So please do read through. This will also be available on Blackboard, but this is on All3DP. It's a really good information website. I'm not going to go through the exact details of all of this, but that's based in rundown. And like I was saying, it is built with a wide selection of, or rather it was created through consortium of many different organizations. Autodesk is one of them. And then software as well, developed by PRUSA, CURA, Autodesk, yada, yada, yada. So all the big ones we're really working with. So that's largely why. So it's an excellent file type, excellent file source. So what does that really mean? Well, let's switch back over to Fusion and let's figure this out. So file format, You can still save this in STL, all that being said, because this is a simple object. But I would recommend just get in the habit of using 3MF as your file type. It's not brand new in that it's going to cause issues in slicer programs and things like that, but it is newer, so older formats and such might have issue. So if you have an older printer, something like that, this MakerBot, I haven't tested 3MF in yet. It might have issue, but Formlabs is fully checked out. PRUSA Slicer is fully checked out, so should be good. All right, so roundabout, selecting file format, 3MF. Okay, let's put it in. I'll just put downloads, Jedi badge as a 3MF. Save. Okay. All right, so I've saved my file now. Let me just go to full screen share here. So we're going to bring up, oops. First, the slicer programs we're using. So first up is PRUSA. Yes. I just updated all this, so it's giving me all the stuff. All right. So this is the two PRUSA printers we're using here. So first up is, you'll see if it is formatted properly, it is a virtual rendering of the print platform. So the great thing about that is you get a sense of scale of your object. Let me bring in my object. You can, of course, use the file search or just drag and drop. So either one works. Open up, Jedi badge. Now, currently it has a little C icon because this computer is set up to use CURA as its main one, but same diff. Drag and drop, plop. Okay, so right there, you can already see how big this is relative to the scale. The print bed is, I believe it's 220 millimeters across by 180 deep, or 200. I can't remember at the moment. But this is also why I was saying that sticking with metric is a good idea, because it translates more easily into these slicer programs. All right. So what I have here, and let me get a better view here of switching over just to actually the PRUSA. All right, so this is the virtual environment. I can see how big my object is. If you say wanted to resize any of that stuff, we can do that. You can also arrange multiples. I can either use the plus minus symbol here, or select the thing, copy and paste the second one. Icon up here is arrange, or press A. It'll automatically arrange for you. But you might find times that you're going to need to arrange these manually, that sort. That's fine. So let me just delete one of those. Use the arrange tool again. So to get you familiarized with the general format here, one, you have all your you have your standard plater tab. Second is print settings. Third is filament settings. Oops, wrong click. Fourth is printer settings. For the most part, we're just going to be using the plater and occasionally the print settings. Once all this stuff is grayed out, you just have to select your actual object, then it'll bring up stuff. So you have your move, standard move, or you can just click and drag it around. Now, with this, it automatically will bring whatever face, it is modeled in your program in as. So in the same orientation, all of that. If it's differently oriented, it'll bring it in as it's oriented in the program. So if you built it on your XY plane, it'll bring it on this. If you built your object on the XZ plane, it'll bring it up flat in front of you. So if that happens, you have the other options here, scale. You can grab it. You have these different cubes, which relate to the different axes. Green, still the Y-axis, front and back. These are going to, if you grab just one, it's a non-uniform scale, non-uniform squish. Don't like it? Control Z. X, still the X-axis, still left and right. Same deal. And again, Z, vertical stretch. Now it's like a big cake. The outliers, the orange, that's your uniform scale. Alternatively, go on to the platform to the right, the tool selection at the right. Let me just Control Z that. You have position, that is moving. So if you want to put that numerically, you can do so. Say, I don't know, 25. Snaps it all the way over there. It's selecting from the center. So don't use that. I would recommend if you need to move it around, just drag it around. You can again drag it. However, it's only going to move in 2 directions. It will not move up and down. That you actually have to grab one of the move tools. So select the actual move thing. You can then use the Z-axis cube to move it up and down. No need. There you go. Rotate can be done numerically the same, or you can use the move tool. Only below is the actual rotate tool. So you click that, it brings up multiple orbits, so it allows you to rotate that sort. So if you need to do that manually, any of that. All right, next tool, very handy. Say you have modeled your object or whatever it is, however it's been imported, whatever, it's on a weird axis. Well, I don't want to print that way because that would be a hell of a waste. Make it as efficient as you can. Now I could grab this and, oh, good God, let me try to, orient this so it's flat. Don't waste your time. PRUSA has a selection box, 3rd or 4th one down, place on face. Select that, rotate around, and you can see that it has highlighted these general areas. I can select just that, it'll snap it to the bottom. Very convenient. Alternatively, if this is upside down, there you go, snap that way. But I want it that way. So there you go. And the last option is cut. We're not really going to be using this right now, but this is so if you wanted to, especially with something that is just straight extruded, you could place a slice in there and you'll actually cut your object into 2 or more places. Or that is also how you can develop stop points if you wanted to change out filament so it get a different color. None of these are set up for multi-materials, so you're gonna select a filament and it's gonna print that as one. Can you change out? Yeah, but you have to do it manually. That's all. Okay, right side is your fidelity and different selection materials, that sort. So upper right, drop down. Same thing as you're printing on just printing up a paper on a regular draft printer. Do you want it high quality so it takes a while but uses a lot of ink and takes up more time? All right, pick quality. If you just want it to spit it out as fast as can be done, pick draft quality. 0.3 millimeter layers. These numbers relate to the increments of height for each time it prints a new layer. Don't use, because we're not the extruders are not set up for this, don't use the ultra fine. We would need to switch to a different nozzle that can print better in that. Otherwise, it's just going to gum up the works. I have really found no real difference, at least for most of the models we've been using, from the standard high quality, which is 0.15 versus the 0.2 quality. Same as the speed, it's just going to make it's just going to cut a couple of corners. If you're just trying to knock it out as fast as you can, use draft. Second selection down is your material. Now, we will be going over the materials here in the room, but for the most part, we have PETG rather, and PLA. PLA is your standard run-of-the-mill, cheap, lots of quality or lots of color options, and it's perfectly fine for most prints. It's not a stronger one, but it prints perfectly well. Your other selection, generic. Oh, I didn't add more filaments to this, so I'll have to do that. What? Don't install right now. Come on. Hey. Okay. Fine. Yeah, just select a lot of them. Hold on a second. Let me pause the record here. Okay, so sorry about that. Had to update. It did not already have these pre-selections in place. Now, the reason you need to make sure that you select the type of material, not just color. Color is, for the most part, irrelevant. These color swatches are simply there as noting whether or not it's generic, PRUSA, that sort of thing. Just the different makers. Doesn't matter. The material type very much matters. They all melt at different temperatures. They will need to be programmed for such. The slicer program does all that for you, but you will need to make certain to select which is which there. Note that, again, MakerBot will only print PLA. Doesn't matter what type of PLA, but it will only print PLA. PRUSAs will print any of it. So we're using mostly only PLA and PET. PET is, I have found to be stronger, just as many color selections. The other difference is that PET is more readily recyclable. Now, that doesn't mean you can just throw it in the recycle bin, but it can be repurposed within itself to like make more filament. That's actually something we're looking into for actually having here on premises on the campus, but that's another thing. So make sure you've selected what type of material. You'll see in the bins over there, they're labeled, and then you'll also see on what's on the side of the spools of the actual filament, it'll say which one. The other thing is make sure that it's selected. Should be the only one selected is for original PRUSA. That's where, or the Mark III, that's what we're using. For right now, we don't need to worry about supports. Infill is the inside of the material. So basically, think of this as a hollow object. If it is selected to 0, you're just printing the shell. Otherwise, think of like bird bones and such. They have like some kind of webbing and such in between. It's not a solid bone, but it's not overly dense. It's kind of mushy and such like that inside. That is kind of sort of what the infill is. And I say kind of sort of because you can select a different variety of actual types. The percentage is going from 0 to 100 is how dense that is. 0, it's just a hollow shell. 100%, it is a solid chunk of plastic. Wholly unnecessary. For what we're doing, 15 or 20%. That's plenty fine. There you go. From there, you'll select Slice Now, the bottom, and you'll see it has completely changed colors and all that kind of fun. There's a legend up here on the left, tells you what we're looking at. Orbit around, I can zoom in. Now it's all line and wavy like that because it's actually representing what the tool path is going to be, what the extruder path is going to be. I can use this slider over here, drag it down, and it will cut through the layers to show you what it looks like inside. And it's just lagging a little bit as I print. Doop-a-doop-a-doop-a-doop-a-doop. Sorry, my computer is very lagging. So right now it is set up as a grid. So that is what is inside the layers. That is what's inside the walls there. Pretty neat. You can change that up by going to the print settings, going to infill, and the fill pattern. A lot of different options. You can leave it as the rectilinear grid. That's fine. I like to use this gyroid or gyroid, however it's pronounced, whatever. Slice, and you can see it's all this wavy lines now inside. All that means is instead of it having to start, stop, and make a bunch of individual squares, gyroid, it makes a parametric flowing form in between. So it just speeds it up a little bit. That's all. From there, I'm going to drag it all the way back to the top. Doesn't matter. From there, you go to Export G code and wherever your file. Now, two things. G code is the standard of machine coding. So this is the same type of software coding that goes into a 3D printer or can go into any kind of CNC manufacturing machine. CNC lathes, milling machine, all that kind of fun. Same diff. In this case, 3D printer, using the PRUSA Slicer, it will also tell you in the file name so you don't get them confused. It'll tell you what the thickness is. It's 0.3 millimeters. The material, PETG. It is made for the PRUSA Mark III's, which is what ours are. And it'll tell you how long it's going to take. So this basic one, which is already in there too, just under 2 hours. Hopefully. So that's it's available. Now, a moment. The PRUSAs do not have an internal memory storage. You have, and it uses SD cards. I've made these little tags on the back. They're just hot glued on there. It's just your standard SD card. They're 16 gigs each. This could carry like each one of these could carry years worth of students' work. It's not. The file types are very small, but you need to load your prints onto an SD card and insert it in the printer. The MakerBot does have an internal storage, but you can use a flash drive, a USB drive, and you can load it onto there. Works great. The SLA printers has an internal storage, and it has to be connected to the computer because you can upload it directly. You can still work on a USB, but those are set up to use directly. So with this one, you load onto here, and I'm going to go into the details of how to actually print in a moment. But just for the time being, if you would like to, you can get this PRUSA Slicer put onto your own personal computer, or you can use either the kiosk computers. They are set up. If you do not have an SD card reader, these stations are set up. This one is not. With a couple of adapters, SD card readers on the bottom. Just plug in, drag and drop. Obviously, you got to plug it in your computer. So if you want to load this onto your computer, your personal computer, it's at prusa.com. Let me switch over to sorry, I thought I already had this pulled up, and I probably already did. But, no, it's at PRUSA. It's at PRUSA software. Dang it, I forgot. It's PRUSA 3D. They got bought out, or somebody else had grabbed the PRUSA thing first. Yeah, that happens. Sorry, I'm just trying to figure out which one it is. There we are. So if you want to download the Slicer program yourself, go to PRUSA. It's not PRUSA.com. It's PRUSA3D.com. I'm sorry. I'll be putting the links for this stuff onto Blackboard, but you can just go to software and just download the Slicer for whatever your operating system is. Windows, Mac, Linux, whatever you want. And it works from there. Works really well. It's a good program. All right. So download the software. There you go. I'll go over CURA another time. Let me bring this up. As well as the Formlabs SLA printers. We're not using those for this project, so it's irrelevant. And of course, now it's going to try and update. I just opened all this up, and the CURA Slicer software is essentially the same thing. Basically, what it's doing, like I said, in any of these, they're called a slicer program because it's taking your three-dimensional model and literally slicing it into a whole bunch of single layers, and that's what it prints each layer as. This is just, of course, taking forever. The difference being that PRUSA, I like a lot more in general, obviously for the PRUSAs that specifically. The CURA, as it's opening, and might actually open at some point, you can directly print in either. There we are. So let me bring up the, now that it is opened. The difference, here's the format. After explaining the PRUSA one, you can pretty much get the gist. You can load, same thing, you can select your printers. In this one, I've already set it up for either the PRUSA or the MakerBot replicator. I don't think it's actually this one. I'm gonna have to test it. But you can see it's a virtual environment of the print bed. Same deal. You select your printer, select your material, PLA, lots and lots here, but we're just going to stick with, if you're using CURA, just stick with generics. It works the best. It's the best selection, and that's largely what we have. But the ones we're using is either PLA or PETG. Same diff though. And then same here. You have your, fidelity here. So you've got your resolution, again, draft, coarse, super coarse. I've not tested the extra coarse on this yet, so I can't tell you how coarse that really is, but I'd probably stick with, like, I wouldn't go any further than draft, maybe coarse. I don't know. You can see by the layer types though. Draft on this one is 0.2 millimeters, whereas CURA, or I'm sorry, PRUSA was, the layer height was 0.3 is their draft, and CURA is 0.2 on their draft. for the same. 0.3 is at there. Cura is extra fast for 0.3 millimeters, and it's the same as draft on PRUSA. So just note the actual layer heights. That's all. Same thing with infill. You can change the infills differently. Supports, we're not really needing that, and you can ignore adhesion because that's unnecessary for these. So you've got a bunch of different controls and such. I have found when I've used Cura to print on PRUSA, sometimes it causes weird bugs. Really just like adhesion, or it slices it a different way. It's not a bad way. It is simply that the dedicated PRUSA slicer works better for the PRUSAs. That's all. So I'd recommend that. So I'm going to record the a demonstration for the actual printers later. So this video will simply be for discussing the printing or the slicing process and all of that, and exporting and then saving onto an SD card. I will go over the actual details in a different video, so I'm going to stop the video here. And of course, everything's pretty self-explanatory at this point, and if you do need help, the forums are excellent help. So best of luck with that stuff.